All right, so we've been doing a lot of graphing sine and cosine and working with writing equations for sine and cosine, but we do need to look at the graphs for tangent and cotangent, even though they're not as prevalent on our AP test. We think about the graphs of tangents, especially a lot in calculus. So recall the tangent of an angle on the unit circle is the y coordinate divided by the x coordinate. And in some of our AP classroom problems, we'll look at the fact that the tangent value of an angle is also the slope of an angle. Because remember, slope is rise over run. So if tangent is y over x, if I say, what's the slope of this terminal line that goes from 0, 0 to pi over 4? That would be a slope of 1, which is also the tangent value. So something that's just kind of interesting, but we're not really going to use that idea for our graphing. Let's make a little x, y chart, input, output chart, just like we did for sine and cosine when we were first doing these. And I'm going to use not all of the same ordered pairs that I did for sine and cosine, but I still want to start at 0. And so if we do y divided by x, 0, we get 0. Let's do pi over 4 as an angle. I didn't do that for sine and cosine because those are not nice integer values, but the tangent of pi over 4, because that's y over x is equal to 1. We should know that from our speed quizzes. And then we'll hop up to pi over 2. Now at pi over 2, y over x is 1 over 0. That's undefined. And we are going to plot more points, but let's graph what we have so far. So we have 0, 0, pi over 4. So on this axis, pi over 4 is right here. So pi over 4, 1. 1 is up 2 units here just to space things out. And just like we did with secant and cosecant graphs, if the trig function is undefined, it means that it has a vertical asymptote going through that x value. Now, instead of continuing on, let's go to some of these negative angles. Let's look at what's happening here. What if we type in negative pi over 4? If our input is negative pi over 4, that sends you down here, right, to 7 pi over 4. What's the tangent of negative pi over 4? It's negative 1 because you're down in the fourth quadrant. So negative pi over 4, negative 1. And then what about negative pi over 2? Because that's how our axis is numbered. Negative pi over 2 is down at the bottom of the circle, just like 3 pi over 2. Tangent is undefined there as well. So I kind of consider this to be our first period of our parent function for a tangent. We need to get the concavity right on this. So from the center to the right, the graph is concave up slightly. And then from the center opening down to the left, the graph is concave down. Sometimes people have a hard time drawing the tangent graph, but because we've talked about concavity a lot this year, that might be able to be a way that you could remember it. Now, this is one period, and this pattern repeats itself over and over and over. So if we look at this, the distance between two asymptotes is pi, or 4 boxes. So if I go another 4 boxes to the right, I should land on 3 pi over 2. That's another place tangent is undefined. And I should be able to copy these 3 nice points. So at pi, you hit 0. At the pi over 4s, you're following the same shape. So to the left and down, and to the right and up. So this is 3 pi over 4, and this one's at 5 pi over 4. And we could just keep continuing. I don't have room to do another asymptote, but at 2 pi, the graph would hit 0. To the left of that, it goes down to negative 1. And to the right, it would continue up. On the other side, we should have another vertical asymptote at negative 3 pi over 2. And just copy this shape over again. So we're using the fact, just like we did with sine and cosine, that this is a periodic function, and we can just keep plotting from there. So tangent curve goes on forever and has vertical asymptotes, so we'll have some domain restrictions to talk about. So when you're graphing tangent, because we're not just going to do tangent x, we'll have transformations. We're not really going to think about phase shifts, or maybe we'll think about vertical shifts a little bit, but we're not going to think about phase shifts. Instead, we're going to first determine the period. Now the period here, look at the original tangent graph. That's a distance of pi. The original sine and cosine graphs had a period of 2 pi. Tangents is just pi. So if you have a value b that's something other than 1 in front of your x, you calculate the period by doing pi divided by b. And again, one period of the tangent curve is one of these branches that goes between the vertical asymptotes. Once you determine the period, find one asymptote. So take whatever is inside of the tangent function, so whatever this expression is, set it equal to pi over 2. I think of this as the original vertical asymptote, meaning like pi over 2 was the first one that we plotted. So that's where that number comes from. You could set it equal to negative pi over 2, or any of the other pi over 2s. Any of the other odd pi over 2s, I should say. And then you solve for x. So I'm not going to solve this for x because we don't have numbers, but you would divide by b and then add or subtract c over, depending. Once you plot one asymptote, you can plot the next consecutive asymptote by either plus or minus the period onto what you have. So say we have an asymptote at pi, I would do plus or minus whatever the period is and plot the next one. And then we're just plotting 3 nice points on each graph. If there's a vertical shift, we would do that either after the fact, or you could draw in a midline if you still want to. All right, so let's take a look at this. So the period here, here's the b value. The period is just pi divided by b. So pi divided by 2. Put the formula in there. The period's pi over 2. I'm not doing anything. I'm not divvying up the axis or anything. To find an asymptote, I take the expression inside of the tangent function, and we always set it equal to pi over 2, because in the parent function, tangent x, that's where one of the vertical asymptotes is. So solve this for x. Divide by 2. Pi over 2 divided by 2 is pi over 4. Subtract pi over 2. Pi over 4 minus pi over 2. Make that 2 pi over 4 to get a common denominator. It's negative pi over 4. So the first asymptote is at negative pi over 4. Let's sketch that in right there. And then the next asymptote would be, okay, we'll add the period onto that. So start at negative pi over 4, add pi over 2 onto that, or I'll use your graph. Pi over 2 is 2 boxes, so another 2 boxes over. We should land right here. Mathematically, it works out, though. Negative pi over 4 plus 2 pi over 4 is positive pi over 4, so that's right. And then plot your 3 points. So the center is always in the exact middle between those two asymptotes. The other 2 nice points that hit 1 and negative 1 are halfway between the center and the asymptote. So if this is pi over 4, this would be at pi over 8. I'm not going to require that you label that, but it's just kind of nice to know. And then concave down on the left, concave up on the right. And then I just need to copy this shape. Every 2 boxes, I should have an asymptote. So at all of the pi over 4s, all the odd pi over 4s, we've got asymptotes, drawing them in. And then I'm just plotting my same shape over and over and over. So yes, it is a little tedious to draw these. We do not have to sketch graphs, as far as I know, for the AP exam, but sketching the graphs is the best way to really learn a lot about what the graphs are going to look like, and then be able to answer questions about the graphs on our AP exam. And again, just watch the concavity on this. I will have you sketching graphs for our test that we have in this class. So you've got to have the right shape. You can't just make up your own function behavior for these. It just takes some practice. And I can't fit a full period, so I'll just do that. Okay, now what about domain? So this is kind of just like what we did with our cosecant and secant graphs. It's all real numbers, except x can't equal. Pick an asymptote. I always pick the first one, or I could just pick the one. How about this? We pick the one that we started with. We got x equals negative pi over 4. Start there. Add the period to that. Multiply the period by k, because from negative pi over 4, you can add any amount of pi over 2s or subtract them, and you'll land on another asymptote. Make sure that you say that k is an integer. I'm saying Kez. Our AP exam will write that out. K is an integer. All right, let's do another one. So start with the period. The period is pi divided by b. So in this case, that's pi divided by 1/2, which is 2 pi. And remember, the period is not, we're not going to say divvy that into 4 equal parts. This is the distance between a pair of vertical asymptotes. Speaking of vertical asymptotes, we take the expression inside of tangent, x over 2, set it equal to pi over 2, and solve. So if you multiply by 2, you get pi. So one asymptote is at x equals pi, and I draw that in. The next asymptote is 2 pi away from that. So I can't, so what is pi plus or minus 2 pi for the next one? Well, 3 pi is off my graph. I don't really want to extend that out. So go the subtraction route. 3 pi minus 2 pi is negative pi. So draw another asymptote at negative pi. This is a horizontally stretched tangent graph because one branch is going to fit in between these two asymptotes. So then when you're drawing that branch, the exact center, which is the origin, is on 0. And then the next two nice points are halfway between that center point and the asymptote. So they're at plus or minus pi over 2. And right here, this number that we've been using as amplitude for sine and cosine, there's no such thing as amplitude for the tangent graph. But remember, that multiplies y values by that number. So where the tangent graph is normally equal to 1, it's going to equal 2. And where it's normally equal to -1 on the left, it's going to equal -2. So this graph has been stretched vertically, dilated vertically by a factor of 2, and dilated horizontally by a factor of 2. And then we can copy that image to the other two sides. So the next point should be at the 3 pi over 2. Well, let's do the center. There's a center at 2 pi. 2 boxes over, we're down on the left. We're not really going to have enough to draw the rest. So, and then here, center at -2 pi, and that would be to the right of that, you go up to 2. And the graph will continue on. We're just filling the window. For the domain, all reals, x is not equal to, start with your first asymptote that you found, or really any one that's on your graph, but I just go with the one I found. Add to that the period, and put a k on that because you should be able to start at one asymptote and add or subtract any amount of 2 pi's to land on another one. So k is an element of the integer number set. What if it's negative tangent? So negative tangent is an x-axis reflection. So normally our 3 points go like this, but we're going to reflect them so that the point on the left goes up and the point on the right goes down. For the period, we've got pi divided by 1. There's just a 1 in front of the x, so the period is pi. To solve for the asymptote, I set x minus pi equal to pi over 2. So add pi to pi over 2, you get 3 pi over 2. So graph that, 3 pi over 2. The next asymptote will be at 3 pi over 2 plus or minus pi, because again, you're going to run out of room here. If you add pi, you get 5 pi over 2. That's not on the graph. If you subtract 2 pi over 2, then you get pi over 2. The next one's at pi over 2. And check your math on that. Just do a quick visual of like, how is this pi units? Pi is 4 boxes on this chart, and this is 4 boxes across. 3 pi over 2 minus pi over 2 is pi. And then you can plot your points. So in the center, we're at 0. Oh, no, sorry. At the center, we're not at 0. We're at plus 2. So if you want to draw in a midline, oh, I kind of ran out of room here. But if you want to draw in a midline, you could and say, okay, the center of the graph, instead of being at 0, is here. Or we can draw in little ghost points if we want to. The negative tangent graph would be at 1 on the left and -1 on the right. So those points go up 2 units. So this one would be at 3, and this one would be at 1. So we've got that. So you don't have to draw these little ghost points if you don't want to, but that might help. Or you can draw a midline like we did for sine and cosine. All right, what about the rest of the asymptotes? So if I go pi units to the left, I'm at -pi over 2. negative 3 pi over 2. And then I'm just going to use the periodic pattern here to match. So one box over, I'm at 3 on the left. One box right, I'm at 1. So there's another section. Same thing with all these others. And last one, we've got that. So this would be, notice the concavity changed too. Oops. Concavity change is concave down on the right, concave up on the left when you reflect. And last one I can fit in here is up here. What's the domain for this? All reals. X is not equal to, the first asymptote I found was 3 pi over 2. Add to that the period, k times, k is an integer. All right, what if it's cotangent? The rules are almost exactly the same. There's only one different. Well, there are two differences. The way that you apply your 3 points and what you set your asymptote expression equal to. So the period is still pi divided by b. We will look at why this is true on the next page, but the original vertical asymptote was at x equals 0. We'll see that on the next page. So set your expression equal to 0 and solve for x. You'll still add or subtract the period to get the next asymptote. And the 3 nice points are going to go in this direction for cotangent. So let's take a look at the cotangent graph from our unit circle before we get into transformations. So we'll make a chart just like we did for tangent. This is cotangent. Remember, cotangent is x over y on the unit circle. If we start at 0, 1 divided by 0 is undefined, so undefined right off the bat. Pick pi over 4 because cotangent of pi over 4 is also 1. Hop up to pi over 2. X over y is 0 in that case. So let's plot what we have so far. We have undefined right there on the y-axis. At pi over 4, the graph hits 1. At pi over 2, the graph hits 0. So let's actually keep going with these positive values. So after pi over 2, the next nice angle will be 3 pi over 4. Now cotangent over here is negative 1. So at 3 pi over 4, we're at negative 1. And then if we go down to pi, negative 1 over 0 is undefined. So here's one period of the cotangent graph. It's got a similar shape. It's actually just the tangent graph reflected. This is what we just graphed when we did negative tangent. So it's concave up on the left and concave down on the right. And then we can copy this pattern over. Notice that the period is still pi. So if you add pi to get to the next asymptote and the ones on the left, basically it's every multiple of pi that cotangent has asymptotes. And then we can sketch in the other points as well. Center, to the left, you're going up, to the right, you're going down. It's kind of just something to memorize, just like we did with sine and cosine. We memorized those shapes. That makes the graphing a lot easier so that you don't have to like puzzle through a chart and try to remember which points land where. All right, so same steps on this one. The period is pi divided by 1/2, which is 2 pi. And again, that's just the distance between vertical asymptotes. To solve for the asymptote, we set the expression inside of cotangent equal to 0. So this is a nice, easy one to solve. Multiply by 2. X minus pi is 0. So x equals pi. So that's easy. And then the next asymptotes are at pi plus or minus the period. So 3 pi or negative pi. So let's plot what we have. We have pi. 3 pi's out of the window, so let's go negative pi. This is another horizontal stretch, horizontal dilation. Plot your 3 nice points, so exact center, halfway between the center and each asymptote. And then to the left of the center is when you go up. Now look at this. We've got an amplitude of 2. I know there's no amplitude for cotangent, but at this nice point, it's going to go up to 2. And then on the right, we're going to go down to negative 2. So vertical dilation of 2, horizontal dilation of 2. And then copy this shape or what can fit of the shape. At 2 pi, you'll hit 0. 3 pi over 2, you're on the left, so go up to 2. And then on the right, at negative 2 pi, we hit 0. At negative 3 pi over 2, we're on the right, so go down to negative 2. We got something like that. What about the domain? All reals. X is not equal to the first one you found plus the period times k. Okay, last example. Well, these are both numbered 5. Whoops. Okay, so this example, we have negative 1/2. So the points instead of to the left and right are only going to go a half unit instead of 1. And also negative cotangent. If you look at this branch, if you reflect this across the x-axis, it's going to look like a tangent graph. So I like to remind myself that just by showing the 3 dots and their correct like slope. Okay, so pi divided by b. So period is pi. The asymptote is setting the x plus pi over 2 equal to 0. So x equals negative pi over 2. Let's sketch that in. We also have this vertical shift of up 1. So if you want to, you can draw in a midline through 1. That might be good to do. What about the next asymptote? Well, it's pi units away. So you can do the math on that if you would like, plus or minus pi, to tell yourself that you're going to land on pi over 2 or negative 3 pi over 2. Or you can use the graph and say, well, on this scale, pi is 4 boxes. So go 4 boxes to the right and land on pi over 2. And keep doing that. So 3 pi over 2, negative 3 pi over 2. So the up 1, there's my midline now. And then let's sketch a negative 1/2 cotangent graph. So exact center is on that midline. To the left, we go down a half unit, which is 1 box in this case. And to the right, we go up a half unit because it's negative cotangent. So I'm following that shape. So something like this. And then copy that shape over and over. Concave up on the right, concave down on the left. Concave down on the left, and just a little bit to the right there. Concave up on the right, concave down on the left. And final set of points here, like that. What's the domain? All real numbers. X is not equal to, first one I found was negative pi over 2, plus the period, pi times k. Now, I keep picking the asymptote that I found. For any of these domains, it would be correct if you picked any other vertical asymptote you have. You could say 3 pi over 2 plus pi k. It doesn't matter as long as that first value is one of the vertical asymptotes you have. It would be wrong to say just pi k or like 2 pi plus pi k. It's got to be something you have an asymptote at. All right, that's it. We've got a worksheet for homework tonight. Please come into office hours if you have any questions.